Hello and welcome back to another video. In this problem, we're told let g of x equal sgn of sine of x. So what does this sgn mean? Well, that's the signum function, and it's also known as the sine function sign. It tells you the sign of the function where it's equal to -1 if f of x, or whatever the function is less than 0. It's 0 if it equals 0, and it's 1 if it's greater than 0, right? So this would be sine or signum of f of x. So here we have the sine function sine. So we're asked to sketch a graph of g. I think we're going to do that first instead of doing it at c, just because I think it's helpful to understand what we're actually dealing with here. So we have the sine function, and we have to graph this first, I feel, to understand what the actual function will look like. So just in pencil, I'm going to graph what the sine function looks like, where it goes up, hits a value of 1, then goes back down, hits a value of -1, goes to 0, and does the same thing on the other side. Sgn, this sine function, takes the value relative to 0. So here, it is above 0, it's positive, so it has a value of 1. From this point to this point, you have a value of 1. When it's actually 0, it's just 0. -1 for the negative values, +1 for the positive values, and actually this seems to be like, I put it at like 1.5, but it should be at 1. 0, 0, -1 for the negative values. Now we can erase our original function and just keep our function g of x. So this is c, the graph of g of x. So we're going to use this, rather than the more abstract definition of it, to find the following limits. So for for 1, we have the limit as x approaches 0 from the right of this function. So we're approaching 0, and that's in the positive values, so we're approaching from a value of 1. 2, approaching from the left is down here, therefore it's approaching from a value of -1. And remember, this represents that when we're approaching 0 from the right, the sign, right, positive or negative of this function is positive, versus if you're coming from the left, the function has negative values, right? Just to remember what that means. We have the limit as x approaches 0. The limit as x approaches 0 from the right and left do not equal the same value, right? 1 does not equal -1. Therefore, the overall limit, dne, does not exist. Next, we have the limit as x approaches pi from the right. So it's coming here, approaching it from the negative values, so it's -1. 5, from the left, approaching it from +1. And again, you can probably see why I graphed it first, because it's really easy to see what the limits are when you've actually graphed the function. And in 6, the limit as x approaches pi, again, from the left and right don't equal each other, so it does not exist. And finally, for b, for which values of a does the limit not exist? Well, it doesn't exist at -2 pi, -pi, 0, pi, 2 pi, for any values of pi. So we can call it n pi, where n is any integer, right? Because at those values, we're jumping from 1 to -1 or -1 to 1, and from both sides, they're not approaching the same value, right? And this is just saying, plug in any integer into this n, where z represents the integers. Any integer you put in front of n, that's going to be a value for which there is no limit. And then c, we have a graph, which we've already done.